Okay, so
Hmm?
we can start with motion perfect and also camera. So let's
Perfect.
start with motion perfect first. Here actually I provided a kind of interesting package for you. So this is
Hmm.
4-axis demo.
Four
Yeah,
axis.
we have 4-axis EtherCAT, and you see over here
Hmm.
on the video we have one axis as a stepper. So
Oh,
this is
stepper. Yeah.
yeah, the below one is stepper, and this is started axis 0. This is axis 1, which is the first axis of the double axis drive. This one, and this one is axis 2, as you see here, and the DX4 is the axis 3, which is the fourth one. Okay,
Hmm.
so you have all the motors in a glance, and for example, if I go to DX4, which is more accessible for us, I can go to the tuning, for example. I can, uh, okay, let me disable it from here. This is the master enable. So with this master enable, all the access getting servo on or enable. So I just disable them because I want to enable from here. Okay. So this is exactly this axis. I mean this model. So I can choose the RPM. This is an RPM because this is the drawing itself. And I can spin it in backward, or I can spin it in the forward. Okay, you see that how it's
Hmm.
reacting immediately. So I can increase the speed. For example, I can set as 1000. Okay, so all of this happens through EtherCAT. So when I set speed over here, actually it will write into jog parameter inside the drive immediately. So now if I spin it, see, the speed is much higher. Let me bigger this screen a little bit. And I can make it a little bigger like this. Okay, just to have a better
Hmm.
view of the menu. So you see, it's moving fast.
Yeah.
I have the option to go up to 6,000 RPM. Okay, this is the 6,000 RPM, by the way. Yeah, but you stay 100, which is more safe, and you can see spinning. So this is kind of option we can move the motor exactly to check the wiring and everything is good. There's no issue, especially the power cable, because you know there's a sequence for UVW. So if you connect the motor in the wrong order, uh, it doesn't move or it come up with the alarm. It's happened for every brand, including the Core Morgan. So this is the case, and um, so this is for ProNet. Sorry, for DX4, we have the ED3M, which is a double axis drive. If you click on this drive, uh, it will pops up a menu for you over here. You don't have the access to move the axis directly from here because it's not implemented and integrated in the Motion Perfect software. It has a different software to access to this drive, just like Core Morgan. But you can see the position of the motor from here. For example, if I spin the motor manually, you see the first axis, the feedback actually change. So it increase or I can decrease it like this. Okay. So this is that, and the second axis, which is the other one, also this one. I can change it. You see it changed. You can see the status, but you can't move it from here. You need to move from the controller. So if I do the master enable, and if I go to, let me get rid of this one. If I go to and pick the base 1, which is the left axis, so if I move it 1, because the unit is 20-bit, 1,048,576, it will move 1 rev, because this is supposed to be a resolution of the 1 rev. You see that? I can repeat it from here. I can increase the speed from here. Speed is 2 is 2 revs per second. So if I increase it to 5 revs per second, if I move it again, it will move faster. Okay? And if I decrease the speed to 0.2, for example, if I move it again, you see it moves slowly, but I can change the speed in the middle. So it gives me the freedom to change the speed, every time I want, and it will apply right away. So this is the case for the other axis. If I want to do that, I can choose base 2, which is this one, and then I can move it 1 rev like this. I can move it another rev. I can move it by a negative direction like this. Okay, and it works perfect. I even can access to the stepper, which is base 0. You see that here. Okay, so if you can see it better right now. So if I move it, I think, let's enable. The point is, actually it's not under my control, because there is a running function called theta in this mode. So let me just stop these programs over here. Okay. If I show you the registration node, where are the the buffers, status. Okay, move buffers, M type, N type, status. Okay, in the status, actually it's idle. So it should let me move it. Oh, you know what? Actually, the unit is small, so it's a 3.35 point something. That is why actually it moves little. So if I try to move it with a bigger value, like move 100, you see the movement. See that? I can move it in positive with 1000. So this value will refer to the unit. So unit is 35.5556, something like this. And this is in pulse, okay? And the 1 rev of this motor will be 12,800. This is the resolution of this axis. So if I move it 1000 positive, you see the movement actually happened there. So this is the case. Minus,
Okay.
I can return it back to where it was. Okay. And then actually, so we have control on the controller on the all axis. So for the smaller axis, I mean for the DX4 axis, which is here, it's based on the drive intelligence is axis to re. So if I want to move the axis to re, I need to pick the base to re from here, and then I can move it one rev. So based on the specification here, one rev supposed to be 1,048,576. This is also 20-bit encoder. So if I move one rev, actually it moves one rev for me. You can move it again, move it in reverse direction like this. Can you see that?
Yeah.
Once I command it, actually it will follow exactly like a good kid. Okay, so this is the case. One thing I want to show you more in addition is the digital I/O. You see the digital I/O display over here?
Yeah.
So this actually represent the how many input and output you have on this project. Basically here, I have uh, turn this camera a little bit. Okay, now you see better. So I have one output module over here, digital output, and this is a stepper.
Mhm.
Okay, so I have one output module which occupied output 0 to output 15. And then the rest of the outputs are the digital I/O on the drive. So I have, let me show you, 5 digital input per axis for this double axis drive. So totally 10 digital inputs. And I have 3 digital outputs per axis. So totally 6 digital output, which one of them actually assigned for the alarm output. So it's not under control by the controller. So I have 2 outputs, digital output per axis for this drive. But for DX4, I have 5 digital inputs and 4 digital outputs, all controllable by the controller. I can show them over here to you. So if you go, okay, if you go here, actually it's exactly shows this is output 0 to output 15, which represent the first module. So I can also appear here. So this is the digital output module for me, as you see, MPN. And the next digital input is for the first axis of the double axis drive. The second digital input group is for the second axis of the double axis drive. These outputs are for the first axis, this output for second axis, and this input and outputs are related to the DX4 drive, which is the trio drive. Okay, I have access to change the status of the digital inputs. I can show you. Where's the okay over here? So I have a bunch of digital inputs terminals. I mean the switch to show you. You see this one? This block is the first axis of the drive. So basically I'm activating the drive input, but it reflects the digital inputs status on the controller because I mapped them on the controller. Okay?
Okay.
And I have the same for the DX4. So as you see, I have 5, 5, and 5, so 15 digital inputs in addition to what I have on the controller, which I don't have any digital input module on the controller, but I have one digital output, which are these two. So if I activate the output, you see the indicator on the module over here. I can disable or enable. So there's the indicator LED on the module that can show me it's on or off. Okay. And then I have the drive digital outputs, 2 per double axis. It depends on the drive functionality, how many axes, how many digital output drive provides for you. All of them mapped here, and you can access to these outputs and inputs as well. How I made it, what I did here, let me expand a little bit the project. What I did here, I made MC config file in this project. Okay, so this is the MC config contents for me. So for first axis, as you see, I choose the position profile, which is the CSP mode over Ethernet over EtherCAT, and then for the drive profile, I choose 3. What's the mean of 3? Let me show you on the ED3M. So if I go to the browse database, and if I choose Eston, because this is Eston drive, okay, and I choose ED3M, which is the drive actually I've been using here. Let me do it again. So browse the database, Eston, and then pick the drive I have here. Okay, so in the profile, you see the profile number 3 that I pointed here. In the position mode, provide me a couple of options, include the digital output, digital inputs, and a bunch of the other options like touch probe and everything. In addition to the target position and control board and status board and actual position, which is essential for every project. Okay, so I have the same option for Trio, because as you see for Trio, which is the axis 3, I also picked 3 as a drive profile. So if I go to Trio drive, and if I pick the DX4 over here, it has the same configuration for me on the profile 3. So I have digital output and digital input involved on the PDO mapping for this profile number 3. Okay. Any question?
No, at the moment.
Okay.
Nice.
So yeah, so you see it's nicely show all the drives like this, and it used the symbol of the drive, which is exactly the same as drive itself. So this is the DX4. So they used the photo of the DX4 and put it here. If I show you a document which shows all the details, let me bring it here. There is a document about the EtherCAT. That shows all the available options. So in this document, if it opens, you see there is kind of a problem here. Okay, no problem. I can open it up again. Okay, so what's going on? There was no response. So in this document, there is part is talking about the different hardwares actually can map in Trio. And then there is a part that actually shows here. You see that? So these are indication of the 2021 axis connected to the same controller, and you see they are from different brands. Discover, CT, you have, I believe this is from Morgan. So you see exactly they use the same picture of the drive just to make it more, visual, what is connected to. So this is a nice arrangement in Motion Perfect. As you see here, actually it shows exactly what it is, and then you can make it also bigger like this by using this one, this button over here. So it looks like exactly the same as the drive you have in front of you. It feels more real to you. Okay, so let me pause. Do you have any question?
No, no, no. At the moment, no.
No.
Mm,
Okay, so
yes.
the next step is to give you access by running the team viewer. So let me pause.
Show us some example of how to do a cam.
Okay, for the camming, yes, I can show you.
Ah, nice.
For the camming, actually, if you want to have the cam, we have a ready-made
Ah, okay, the
option
that one.
here, cam generator. Okay,
Generator.
so if I add the generator to my project, actually it will provide me make a program, specific program for cam profile. Okay, you can hit it okay, and you can see it will appear in a list of the programs like this. Okay,
Okay.
and and in this menu actually you have different options from here. So you can have an offset plus sine curve, offset plus sine plus speed curve, offset plus sine plus speed plus constant curve, piecewise curve, acceleration curve, speed curve, and position curve. So there are different options. For example, if you stay with the first option, it's this function actually using the table variables inside the controller to assign the points for the cam. Okay, so you need to define the table starting address, which is 1000. It means it will start from table number 1000, and then points, and then the distance, and then lead in the phase and lead out the phase. And for the move command, actually, you can use the cam or cam box. So let's stay with the cam, and you can define what is the move address, move axis, sorry. So you can pick any axis. You can, for example, start with axis 0, and then link distance, what's the link distance, and what's the axis speed. Once you confirm all of these options, it will generate the code for you over here. Okay. So this is a simply creating a cam function based on these specifications. And you can copy this table and paste it into a program for yourself. So it will be exactly the same as the graphic you see here, like this. You have the other options. For example, I have some customers, they have a table, something like a spreadsheet, an Excel file with a couple of the points, and they want to create the same movement profile in an axis. Okay, so we have an option for this, which we call piecewise curve. Okay, if I change the profile to the piecewise curve, in this case you can add more points for yourself. Okay, and then you can choose what type of the move command you want to issue for that cam or cam box. So for example, if I use the cam, there is an option. If you right click over here on this table, it will provide you an option here, import from CSV file. Okay, so you can go to your hard drive and somewhere you may have a CSV file with the ready made numbers and ready made positions. It, it can be how many you need, because we have 5,000, 1,200, 512,000 tables. I mean 512,000. This number of the tables are available to have, this big of the numbers for making a profile. So we have a big memory for that. But definitely there is no, CAM function with so many numbers like this. But this is the limit for you. Anyway, yeah, you can insert a CSV table. I had a customer, I remember, a few years ago. They had a special actuator. They had uh, a, an Excel file with all positions and the speed and everything, and the actuator must follow exactly the same trajectory for them. So I helped them to insert the Excel file right from here, and then they had that project. I think I should have that one, but yeah. This is the way to using the cam profile like this. Very easy. Any question?
No, no.
We
Nice.
have we have also, if you go to the help file, and if you go to motion perfect, okay, it shows more details if you want to be looking for the cam function. Tools, also let's go special programming and file, no project, no solution, main window. Uh, it's somewhere here. Uh, Oscilloscope, intelligent drive, robot, controller tool. It should be here, I believe. Memory feature. Yeah, there is a comprehensive document somewhere. Oscilloscope, intelligent drive, robot. I do remember we had a document here for CAN function as well, but I can't see that options. Plugin, general, IEC, HMI. Yeah, you see there are some handful document for HMI and also for IEC language. Uh, Let me expand it a little bit. Cam. Let me search it. Cam. I believe we have controller tree. Or maybe it's not here. Let me check. Maybe there is a specific. Oh yeah, it's here. Sorry. Cam generator help. So if you choose this help file, actually it has all the details for your to learn, how to use the cam function. Make sense?
Oh, yeah.
Cam
It's good.
editor.
It's
Yeah.
good.
So all the options actually defined here. Okay.
Okay.
So you can get, yeah, get some hands on this function. By the way, you can also use the offline simulator, to experience the functionality like this. Yeah, but this is the way actually to generate a cam function. Any other question?
Just if we can see some example how to simulate with the 3D movement with the drawing.
Okay. Yeah. Yeah, definitely for uh, 3D visualization, we call it 3D visualization function. For 3D
Mhm.
visualization, you need to go to this menu, okay?
Okay.
And then if you click on that, it will open up uh, uh, a window like this. But at the beginning, actually, I already had this 3D model myself. This is the printer 3D model
Mhm.
that I use that I use it for some uh, simulation and training before. So all of them actually, if I go here uh, for the setting, you see I can access to the different joints, different different parts, and then I can move it like this. You can scale it from here based on the resolution you have on the project. So it's completely open to you. You can insert any number which will specify the resolution of the movement over here. So if you have a project, a real project, for example, that you want to simulate it over here, and you have a specific encoder, for example, 20-bit encoder, uh, and you want to scale it in tenth of degree or tenth of radian or any unit in the 360, for example, you can have the number in your project and then you can set it up over here. And also you have the parts. There are this is very comprehensive uh, menu. You can uh, add the parts. The parts actually made this axis and join this axis together. Okay, so let me show you one of the visual one. These are all components actually you see joined for moving this axis. So let me find, yeah, you see that? Like this, like this. So these are the parts actually joined together. This is the roll. So the parts with are bold are the parts actually are visual here, just like this one, like this one. Yeah, but yeah, it gives you functionality to insert any 3D model and then join them together as a one part. And then when you move the axis, which is assigned to the specific axis number, all the parts joined with that will move together. For example, if I move this one, you see the roll also is moving, but because it's flat color, you can't see that, but you can see this one because of this point, which makes it visual for movement like this. I can move the other axis from this menu, like axis 1. Okay, so this is something I made myself, but you can also import from this part uh, something that you made yourself by choosing the new machine. We also have some sample machines from here. You can choose them. We have the gantry axis. Cannot process. Please complete the editing. Okay, I can complete the editing and then go here and load the machine, sample machines, gantry. So this is what you have basically built in the motion peripheral. So this is the gantry axis. I already showed you in the first or second session, I believe. I had one customer actually that they use this type of machine, 5 axis, and when you enter the model, actually it gives you the option to uh, bond the axis, so you can define the axis number for this specific joint. For example, I can define it as axis 3, for example. It's better to be set it as a dpause. I can set it at axis 2, for example. Dpause again. So if I go to Oh, I need to save it as a file if I want to do some editing on that. Yeah, so this is the way actually you can import a 3D model in your project. So based on what type of project you want to do, you can ask the customer to give you a simplified 3D model to enter to this menu, to this part of the software. Why simplified? Because if they give you a 3D model with 100 pieces, it takes time for you to join all of these pieces together, which is one problem. Then the second problem actually is the processing speed for the PC, because if it's a complex model with the 100 parts to be moved together, actually it takes a lot of resources from the processor in your PC to run the model. So it's better to ask the customer to get rid of the unnecessary part, just give you a simplified model to make it lighter, to run it here, which is much easier for the software and for your PC, to run it out. Is it clear? Any question? Yeah, this is kind of the brief introduction. Okay,
Eh,
so if you have some model
oh,
that you want to insert into the motion perfect, actually there is a video, I can share it with you
okay.
later, but I can run the video quickly here for you. um, the video actually is talking more details, showing more details to you. So, through application instructional video here, 3D visualization. Okay. 3D visualization. Is this the? I think this is not the right video. Oh yeah, yeah. Okay, so this is one of the simple application. This Coca robot or is also built in uh,
Mhm.
into the 3D visualization. So you see it's bond different joints to different axes like this, and then it can
Nice.
run. Yeah, it can run it, but after starting the simulation, and there is a program actually behind that which moves the axis. So this is what will happen exactly uh, on the project. You can stop, pause different joints, and let specific joints to move only, and you can enter a desired position for that joint that you already paused. You see that? It's very flexible,
Yes.
very interesting. If you want to have this option in Siemens, for example, or in Allen Bradley, you should pay, I believe, more than $10,000
10 times.
to have it active
Wow.
only in one PC.
Oh.
Yeah.
Another question for Scar robots.
Uh
I
huh.
understand that you have on our products, right? The or all the complete robot you can sell.
We have the all complete robot. Yeah, exactly.
Could you share the prices and lead times?
Yeah. Do you have the specific project for that?
No, not really, but uh, I know